Hi folks. So I decided just to make a little bonus video for any that are finding some of this vertex form stuff in this unit a little bit confusing. And if you're finding it totally fine and you're really overwhelmed by some of the other work and the amount of work you have to do on other stuff, this is totally an optional video and it's not essential. But I think it might help to answer a question that commonly comes up in this unit, and one thing that's often a bit challenging or tricky for students to grasp at first. Now, of course, what's really annoying about this sometimes is that we have to remember in this general form of the vertex form that we have this x minus h inside of the bracket. And not only is that strange to see in the original or general form of it, it has a bit of an annoying effect when we actually write out specific equations. So for example, if I write out a specific one in vertex form, something like maybe this, well, the fact that in my general form I have x minus h leads to a bit of a confusing situation when I see a plus inside of the bracket. What we've noticed all along is that, for example, if I have a positive number inside of the bracket, like I have +3 here, what that ends up telling me is that my h value, or the x coordinate of my vertex, always ends up being the opposite sign of that. It ends up being, in this case, -3. And for some of you, that might be no problem at all. You might just recognize that, oh, this is a little additional rule that you need to remember. For others, though, you might be really bothered by that and kind of wondering, why do we have to do that? Why is it the opposite? And why doesn't k seem to work the same way? Because one nice thing about the k value here is that k value tells you exactly what the y coordinate of the vertex is as it's written. And so +5, as is actually the y value of the vertex. But again, why is it that this h value has to be the opposite? Why is it that my h value is -3? And I don't want to just say that, oh, that's because that's the way it is in the general form of the equation, because then you might ask, why is it that way in the general form of the equation? Well, let's think about this for a second. Remember that a vertex point occurs at either a maximum or a minimum y value. It's either the highest point on a parabola or the lowest point. And which of those it is depends on which way the parabola points. So first off, just keep in mind that this has a positive a value. So this would be a parabola that points upwards, something like that, which means that its vertex point down at the bottom would be its lowest possible y value. So if we want to find the coordinates of the vertex, we're trying to think about not only what is the lowest possible y value that this could take on, and what's the x coordinate that goes with that y value, or the x coordinate that leads to that y value being the smallest it possibly can be. Well, let's think about this equation overall that we have and try and think how we could make the y value the smallest it possibly could be. Well, keep in mind that if y is all by itself on the left, then that means all of this stuff that we see on the right is really a calculation of the y values. We plug in a certain x value, we do this big calculation on the right, and we find what the y value is. So in other words, we're trying to find a special x value that will make this whole calculation a minimum or as small as possible. Trying to find what will make this as small as possible. And if we can find what will make that calculation the smallest possible number it could ever take on, we'll know what the y value is of the vertex, because we'll have found the smallest possible y value. So now we have to ask, how could we make all of this stuff on the right side the smallest possible number we can? Well, I'm going to get rid of some of this stuff for a second. I'll just back myself up so we can clear that out of the way. How can we make this, all of this stuff on the right side, as small as possible? Well, hopefully we can agree that there isn't much we can do about this part here. No matter what x value we sub into the equation, we're always going to be doing something to it, but then eventually adding 5 at the end. So no matter what, there's always going to be a +5. What about all the other stuff, though? How can we make this piece as small as possible? Well, nothing much we can do about the +2, so no matter what happens inside the bracket, it's going to be multiplied by +2. So really we're asking then, how can we make this piece as small as possible? Well, first of all, if we know that it's going to be negative, that might be helpful, but it's never actually going to be negative. Because even if we get a negative inside of this bracket, we're going to square it. So this whole thing overall is always going to be positive. So, again, backing this up, getting this out of our way, now we need to think, if this is always going to be positive, it's always, in other words, going to be greater than or equal to 0, then what's the very smallest it could possibly be? Well, if it's always got to be greater than or equal to 0, then the smallest it could possibly be is 0 itself. So then we have to ask, what special value for x would make this whole thing equal to 0? Well, if you think about that for a second, the special x value that makes this whole bracket piece equal to 0 happens to be the exact opposite sign of the number that we see inside the bracket with it. In other words, the perfect number that would make that bracket as small as it can possibly be is -3. Or in other words, the x-coordinate of our vertex will always be the number that makes this bracket equal to 0. Now, the more of these you do, you'll realize that there's a special pattern that emerges there. Of course, the special x value that always makes this bracket equal to 0 will always be the number with the opposite sign as the number you see in the bracket. So our h value that we're looking for is a special x value that is essentially going to make the entire bracket piece equal to 0. But of course, the shortcut to realizing this is to say that my h value will always be whatever x value has the opposite sign to any number that I see inside the bracket with my x. If that was a little bit of a confusing explanation for you, that's totally okay. Because as I've said all along, all you need to do is know the rules and follow the basic rules and patterns that we've discussed. But if you're one of those people sort of asking, why does the vertex form work this way? This is the reason why. We are trying to find the x-coordinate when the y value is at a minimum in this case, or this same logic would work if we had a parabola that was pointing down and had a negative value. We would still, to find its maximum value, need to find whatever x value makes the bracketed piece equal to 0. And that always happens to be the exact opposite sign to what we see inside the bracket with the x. So if we see something like x plus 3, then the special x value that makes it equal to 0 in that bracket is -3. And suddenly that means our h value, or the x value of our vertex, would be -3. Now, we also can then mention, if that whole bracket becomes 0, and then we multiply 0 times 2, that's also 0, and suddenly the y value that occurs at our minimum point is simply this value, because everything else at that special x value has become 0. And suddenly our minimum y value is actually exactly what that k value is. That's the way we can use this vertex form to find h and k, and that's why that vertex form works the way it does.